In this chapter, I'm going to begin the discussion of how we can implement the Paris Climate Agreement. This is a very bold and challenging limit that we have set ourselves to keep warming well below 2 degrees Celsius compared to the pre-industrial level, knowing that we're well more than halfway to that point already. Now, the essence of achieving the limits on global warming is to stabilize the concentrations of greenhouse gases in the atmosphere. Remember, the greenhouse gases absorb the infrared radiation that the Earth radiates to space, and by capturing that infrared radiation, these greenhouse gases warm the planet. The major human-emitted greenhouse gases are carbon dioxide, methane, nitrous oxide, and some industrial chemicals, such as hydrofluorocarbons. And the main way to achieve the Paris Climate Agreement is to stop the continuing emission of these greenhouse gases by changing our behavior and our technological systems so that the carbon dioxide in the atmosphere stabilizes and even starts to fall. Similarly with methane, nitrous oxide, HFCs, and the other anthropogenic or human-made greenhouse gases. Now, by far the most important of the greenhouse gases is carbon dioxide, because this is the main human driver of warming. And the carbon dioxide is mainly being driven by humanity's use of fossil fuels. That means the carbon-based energy that we essentially dig or pump out of the ground, coal, natural gas, and oil, petroleum. When we combust coal, natural gas, or petroleum, the carbon is oxidized. It combines with the O2 in the air and it produces CO2 while releasing energy. The energy is what we want, the CO2 is what we don't want, because that carbon dioxide goes into the atmosphere, raises the concentration of carbon dioxide, increases the greenhouse effect, warms the planet, threatens the ice sheets, threatens the storms, threatens the crops, threatens the human health, threatens the spread of disease, threatens the droughts and floods. And so that's our problem. In addition to burning the fossil fuels, CO2 also is emitted in one other major way, and that is releasing carbon and carbon dioxide from biological storage. And CO2 is stored, in effect, in the forests and the soils and the grasslands of the world. And when we chop down trees to clear a forest for farmland, we are releasing carbon dioxide into the atmosphere. The estimates are that roughly 80 to 85% of the total CO2 emissions are due to energy use and other industrial processes, a bit coming directly from the processes to make cement, and about 15, maybe up to 20% of the CO2 emitted by human activity comes from land use, deforestation, or changes of land patterns, perhaps to grow food or to take other actions that release CO2 from the soils and the forests and other vegetation. So a lot of our focus will be on the fossil fuel use because that's the main driver of the main anthropogenic gas, carbon dioxide. Now, I should say very quickly, though we won't cover it in a lot of detail, that methane and nitrous oxide, and indeed the other fossil fuels, also need to be controlled. And they also are emitted through a complex and multifaceted set of human processes. Methane, for example, is released by our livestock through the anaerobic respiration of ruminants like cattle. So when we grow beef, there's a methane side effect. Methane is also released through anaerobic respiration of flooded rice fields, rice paddy. Methane is also released from waste dumps. So you have to make a list. What are all the ways that humanity emits these various greenhouse gases and what can be done about them? Nitrous oxide, that is created in part through combustion processes, dirty combustion. It's also created in part when we put nitrogen-based fertilizers on the fields, and there are chemical processes that in which that nitrogen isn't just taken up by plants, but is released directly into the air as nitrous oxide. So truly we need a full inventory of all of the anthropogenic, that is human-caused greenhouse gases, all of the ways that they are emitted, and all of the things we can do to head off those emissions, so to stabilize or reduce the concentration of these greenhouse gases in the atmosphere. That's a long, complicated story, but we're going to focus mainly on carbon dioxide, and in focusing on carbon dioxide, we're going to focus mainly on the fossil fuel use, because that is, after all, the number one driver of human-made greenhouse gases. There's a very important concept called a carbon budget. It's so basic, so important, that I have to say, may sound a little bit cynical, and if it does, it is so important that governments didn't dare even mention it in the Paris Climate Agreement. You won't find the phrase carbon budget in there, but boy, you'll find it in every article on what we should do. Because the carbon budget says that just like a budget of a household, where you should not overspend your budget, or a budget of a government which says if you overspend and you borrow, you go into debt, you could go bankrupt, there's a carbon budget also where the scientists are telling us, do not over-emit this level of CO2 lest you put the planet in mortal peril. And to put it very specifically in the Paris Climate Agreement context, there is a carbon budget to achieve the well below 2 degree Celsius limit, or the 1.5 degrees Celsius limit. That carbon budget tells us how much more CO2 can we emit and still be safe? Or if we emit more than that, when are we likely to go over the limits that have been agreed in Paris? Now, let's start at the beginning to understand how to use a carbon budget, just like a household budget that we each need to obey. This is a graph showing the upward curve of carbon dioxide emissions, especially the emissions coming from energy use. And what you see is the flow of emissions, how much is emitted every year, basically tripled from around 12,000 million tons of carbon dioxide. Let me put that in an easier way. 12 gigatons, or 12 billion tons of carbon dioxide emitted from energy use back in 1965. Then look at that curve going up, 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 up. And by around now, around 2015, we're at about 36 billion tons of carbon dioxide released into the atmosphere because of coal, oil, and gas combustion. And this graph is actually helpful also in understanding, why is this curve rising? Why is it rising so fast? And the top line separated by major countries shows China. China has had a huge increase of emissions over the last 30 years because China is a huge economy. It's growing very fast. It burns a lot of coal to provide the energy for China's big and growing economy. The red part at the bottom of this graph is USA emissions. They're very large. Historically, the US was the major emitting country, but they haven't grown anywhere near as fast as China's emissions because the US, as a mature economy, is growing less rapidly than China. It's less coal intensive, and coal emits a tremendous amount of carbon dioxide per unit of energy. Well, the world as a whole has been on an upward path of CO2 emissions. And by the way, if you look back at 1992, that's an interesting year for us because that's the year that the UN Framework Convention on Climate Change was first signed. You don't see any downturn in emissions after that, even though that was the idea. The emissions continue to grow, accelerate, grow more, because the signing of the UN Framework Convention did nothing to slow down emissions. That's why we had to wait actually 23 years in order to get to Paris and to say, oh my God, our backs are to the wall, we're almost to the limits of bearable safety, and now we have to stop this upward sloping curve.